All right, so today's flipped lesson is going to be on triangles. We're going to start, the first few things we're going to do is just go over some vocabulary. So the first things you need to fill out, we've got the sum of the angles of a triangle is 180 degrees. Got a right triangle, has one right angle measuring 90 degrees. An isosceles triangle has two equal sides. The third side has two base angles that are always equal. And finally, we have an equilateral triangle, has three equal sides where all the angles measure 60 degrees. All right, let's go ahead and get started with our first example. So we're going to find the measure of a third angle. So for example 1, I want you to write down, we've got the measure of two angles of a triangle are given to be 42 degrees and 68 degrees. And we want to find the measure of that third angle. So what we're going to need is to use the fact that we have the sum of the angles of a triangle is 180 degrees. So let's go ahead and get started on the setup for that. All right, so let's start with, if we have a triangle ABC, we know that angle A plus the measure of angle B plus the measure of angle C is all equal to 180 degrees. And we'll go ahead and let X equal what we want to find, and that is the measure of the third angle. Okay, so we can go from here, we can take this equation, we'll set up an equation involving X and solve. So what we will have is X plus the two angles that are given to us, which were 42 and 68 degrees, and we know that's equal to 180. So go ahead and from here we're going to solve for X. So we've got X plus 110 equals 180, which tells me that X must equal 70. So the third angle has a measure of 70 degrees. All right, so on to a couple more definitions, theorems in this case. First one of the most famous ones that many of you probably know, we've got the Pythagorean theorem, which states that in a right triangle, it's always true that we have this relationship, a squared plus b squared equals c squared. And then what we know is, conversely, the converse of the Pythagorean theorem states that if we have that relationship, a squared plus b squared equals c squared, then it must be true that we have a right triangle. All right, so on to our second example. What we want to do is, using the converse of the Pythagorean theorem, we'll determine whether or not a triangle with sides 15, 25, and 20, whether or not that is a right triangle. All right, so what we want to do is see if this relationship works, and then using the converse, if this is true, we know we have a right triangle. So let's go ahead and check that. So using a squared plus b squared equals c squared, we have a equal to 15, b equal to 20, and c equal to 25, where c is always my longest side. All right, so from here we're just going to go ahead and plug into our equation and see if we have a true statement. So plug in for a, b, and c. We got 15 squared plus 20 squared equal to 25 squared, which gives me 225 plus 400 equal to 625. And that is indeed true. 625 equal to 625. So it's true that a triangle with sides 15, 20, and 25 is a right triangle. Okay, and finally we're going to use, for our third example, we'll still be using the Pythagorean theorem. So for our third example, we've got, if triangle XYZ is a right triangle with angle Y being 90 degrees, I know that XY equals 14 and XZ equals 50. What I want to do is find my third length of my triangle, which is YZ. So first thing we're going to do is we're going to sketch this picture. So when I sketch the triangle, I have a right triangle where Y I know is my 90-degree angle, and I have X, Y, Z is my triangle. Now what do I know from back up here? I know that XY was 14, I know that XZ measures 50, and what I'm trying to find is my YZ. So using Pythagorean theorem, I know my A, my B, and then my C length is always that hypotenuse or that longest side. So we'll go ahead and set up the equation for the Pythagorean theorem and solve. Where I've got side xy squared plus side yz squared equal to side xz squared. I know xy was 14, so I'll go ahead and plug that in. Yz is what I'm trying to find, and finally xz was 50. So let's solve for yz. 14 squared is 196. 50 squared, 2500. So I have yz squared equal to 2,304, and believe it or not, that is a perfect square. So I know that yz is equal to 48. Okay, and finally, our phrase of the day, to make sure that you did this on your own and didn't copy someone else. Math is radical. Thank you very much.